Alright, so a calculator is a great tool here. This is actually a thing. If you don't know your multiplication tables very well, this is quite difficult. So as I look at this, if I had a calculator, I'd definitely pull a calculator out. Let's see who's got their calculators today. I'll just get a calculator to do it.
Either way, I'm passing.
Do you have paper today?
That was wrong. I got full my gun now. From 70.
No.
Alright, so I'm looking around. Everybody at this point, while you're still getting it out, has paper and pencil out. You got paper and pencil today, Colton? Alright, I'll give you paper.
You should have agreed. You should have agreed. Yep. Move.
Alright, I guess we're ready. So, I'm gonna go ahead and start. You guys are gonna be quiet. You're gonna take your headphones off, put your earbuds out. That's 2 people with headphones on. Don't stand at earbuds, but if you got an earbud in, please take it out. Alright, so for number 1, I'm thinking about numbers at square root, and the problem is it says no decimals. That's the challenge of this. I do want you to know that this is important in geometry. Raise your hand if you've heard of the Pythagorean theorem. Yes. A squared plus B squared equals C squared. It doesn't know that one. So that'll be revisited in geometry. And you won't be allowed to use decimals. When you solve that, use square root. You're going to have to leave your answers in simplest radical form. Please put your phone away. Okay, so anyway, this is a warm up to get you prepared for geometry. So for sure a good 2 to 3 questions on your exam involving this, because they want you to show that you can simplify radicals before they approve you moving on to geometry. So for number 1, when I look at 72, the square root of 72, if I put it into a calculator, it tells me like 7.5. No decimal answers. So I just need simplest radical form. So I have to look at this number and think, can it be divided? Can this be divided by a perfect square? So then the only way to do that is to know what perfect squares are. So I look at 72. And here's my list here. I'm going to extend it until I get higher than 72. My perfect. What's 8 squared? So I got 64. And then 9 squared, I get 81. So I start high, and I think, does 72 divide by 64? Does 72 divide by 49? Does 72 divide by 36? Does 72 divide by 25? Which one of these will 72 divide by? 36. 9 and 36. Good job, you guys. Now, that's why I said a calculator is really helpful. Okay? we're gonna rewrite 72 as 36 times 2. Now, if there's 2 like this, try to pick the highest one. So start high and then work your way down as you're gonna go to this. So it turns out 72 is the same as 36 times 2. Check your calculators. Is it the same? 36 times 2, 72? Yeah. You gotta check it. You gotta use your tools. It used to be we had this whole part of the exam where you weren't allowed to use calculators. And students said, I can't even prove I can do this because I just don't know that 72 divides by 36. So now we say, you're right. Use a calculator, show you can do this. But some of you are allowed to use calculators and you're not doing it. So grab a calculator, use it. So now that I've rewritten this, 36 square root. The square root of 36 is 6. So I'm going to square root that. The square root of 36 is 6. 2 does not square root. The square root of 2 is a decimal, so it stays the same. This is the answer. Simplest radical form. This is required on both the algebra final exam and the geometry final exam. It's like a double standard. Then it's already simplified. Or you could write already simplified or drag and drop already simplified. Number 2. Okay, now I'm going to go ahead and predict this one's going to take us more than one step because it's a very high number. Sometimes you have to do the process more than once with really high numbers. I'm actually going to tell you the easiest way to do it. But have you guys tried it yet? We got 10 squared is 100, and that's typically as high as I usually make a list. But I also know 11 squared is 120. Does anybody in here know 12 squared? So when I saw this number, I thought of 144 because I practiced a lot. I don't think you guys necessarily look at this and see 144. But 144 is going to be the quickest way to the right answer. So how can you rewrite 288 using the number 144? Yeah. Can you finish it from there? What do we do next? So I'm going to split it up. Yeah, 12. And this is actually the square root of 144 is actually 12. The square root of 2 is stuck. You're going to see that number stuck a lot. And that's the answer we're looking for. Now, there's longer ways to do that if I would have started, for instance, with the number 4. Does anybody want to see the longer way? Okay. Did you? Yeah. Did you think of the number 4, or is there a higher number you thought of? 36, did someone say? What's this divided by 4? Oh, shoot. What? 72. Okay, so maybe, what if accidentally you thought 4 times 72? Right? Then this would be 2, and you would have 2 and 72. Oh, let me get a calculator. No, 288. We're doing the 288. So you would square root the 4, the 72 would be stuck here, but this one keeps going. So now 72 is the same as 36 times 2. The 2 is still here. The 36 can square root to be 6. And there's still the 2 out front, and you get to the same answer, 12 square root 2. But that's if you don't pick the right number right away. If you pick a small number, you go through the process more than once. Do you follow that through? You're just going to have to keep going until your radical can't be simplified anymore. So it's okay if you start smaller, you just might have to do the process more than once. Okay, try 80 now. The right thing to do is to grab a calculator and try 80 divided by 49, 80 divided by 36, 80 divided by 25, and go down this list of numbers until you find one that works. Does 80 divide by 16? So when I think of 80, I think of 8 and 10. But neither 8 nor 10 are in the list. So 8 and 10 are not useful to me today. Instead, I want to find a number in this list. Turns out 80 divides by 16. This is the same as 16 times 5. And you had to prove in pre-algebra that you could square root 16. So you're supposed to know right now that the square root of 16 is 4. The square root of 5 isn't a number that square roots, it's a decimal. So the 5 is stuck. This final answer is 4 square root 5. Number 4. So this middle row is more complicated because of the numbers in front. The first row doesn't have numbers in front. The middle row does. The last row is cube roots. So it's definitely more complicated. Christian, when you see this 8, you think about square rooting it. Does 8 square root to make a decimal or an integer? It makes a decimal. The square root of 8 is a decimal. So I'm going to come to my list and I see that 8 will divide by 4. So I'm going to rewrite 8 as 4 times 2. So there's this 4 out front, staying out front. The 8 I'm going to rewrite as the square root of 4 times the square root of 2. So what? No, I did not. Look at this one. No, I can square root 4. Yep. The 4 is there, the multiplication sign's there, the square root of 4 is 2, and that one's stuck underneath. So this answer is 8 square root of 2. So it's really just a number game. Okay, so this last row, there's the index of 3. So I no longer want to divide by these numbers. I want to use the list of numbers to the third power. It's a whole different list. Okay. When you do a cube root in your calculator, yeah, you're right. 16 does not cube root. Did you rewrite it? Okay. So moving on to number 5. I'm going to ignore the 2 out front, and I'm focusing all my attention on the 32. Using my list, I'm trying to find numbers that 32 will divide by. I believe 32 divides by 16. Anybody confirm that? Okay. So I'm going to rewrite this, the 2 outside, and 32 I'm going to rewrite as the square root of 16 times the square root of 2. It's still 32. Now, like I said before, the square root of 16 is 4. That's 16 square rooted. So this is still out front. Did I just do this one? Oh, it's very similar. It's the same answer. 8 square root 2. Whoa. Very similar. I'm excited. Wow. Very neat.
Yo, Tyler, so I got a question.
Don't ask me no question.
No. They don't got nothing to do with this. What's in the A?
I bet that's all time. Do you know the square root of 64? Yes. Our next one is a 64. 8. It's 8. Okay. So this one we don't have to rewrite as 2 because 64 is actually in the list. 64 does square root. So that one doesn't have to be rewritten. It's just 4 times 8. So that answer is a 32, and there's nothing stuck underneath because 64 is a perfect square. All right, moving on to cube roots. So these 3 use a different list. You have to look at the powers of 3 if you're cube rooting. In algebra 2, we 4th root, 5th root, 6th root. You actually are supposed to in algebra 1 as well. But just figuring out square root and cube rooting is very good job. So the weird thing about cubes is that cubes can be negative. Square roots cannot be negative, but cubes can. I'm gonna write that. Perfect cubes can be negative. So I don't know if you ever saw this, like when you try to square root negative 25, the answer is not a real number. Anybody familiar with that? Square rooting negative is not real. And the reason is because negative 5 times negative 5 is a positive 25. So you can't get a negative number by multiplying something by itself. So this is an impossible scenario. This is not real.
But what did that go for?
Yeah, none of these in this list can be negative.
So the squares can't be negative, but the cubes can.
Yeah. None of these can be negative, but as soon as you go to cube roots, they are allowed to be negative. Because Let me look at a number in that list. So 125 is in the. I'm going to put a 3 here, and I'm going to do a negative 125. There's a negative under the radical bar. If I think to myself, what is negative 5 times negative 5 times negative 5 a third time, what's going to happen? These two will be positive. A negative times a negative is a positive. There's one more, that third one. 25 times negative 5 is a negative 25. It does come out negative. So this answer is negative 5. So any odd index is allowed to be negative. None of your evens are.
I guess that just surpasses belief.
So there's fifth roots and seventh roots. Those can all be negative. But square roots, fourth roots, and sixth roots cannot be.
So the evens can.
There's never infinity. Cube roots are probably the most important because the cube is like a volume. The volume of a cube is length, width, and height. It's a three-dimensional figure. So anything three-dimensional is more like a perfect cube. A two-dimensional figure, very flat, is a square. But in our world, we're working in 3 dimensions. These cubes are actually more important in science. Anyway, the cube root of negative 1 is negative 1. That's because negative 1 times negative 1 times negative 1 is negative 1. And then when I look at this, 16 is not in this list. But 8 is. So I'm going to rewrite this one. This is going to be the cube root of negative 8 times the cube root of 2. That is a really difficult transition. 8 wasn't in this one. We're using this one. Very difficult. So the cube root of negative 8 is negative 2. And the 2 is still stuck underneath. So here's our answer. How'd it go, Phyllis? Did you finish that one up? Yeah. Alright, so again, I see the little guy in here is a 3. All along, by the way, there's been invisible 2s. There's an invisible 2, an invisible 2, an invisible 2. If I could go back and write the curriculum, we would start writing 2s in there. And then you would question, oh, could something else be there? It's always been invisible 2s. Mm-hmm. Well, for centuries, scientists and mathematicians, they only ever square rooted. Centuries. And then someone's like, well, can we just do the opposite of these two? And then that's when they started writing them in. The first person to square root didn't think there was going to be anything but square roots. There's a lot of things in math like that, or the original is invisible. Okay, so how should we rewrite 250? 125? So that's the same as 125 times 2. So the cube root of 125 is 5. 5 times 5 times 5. There's still this 4 out front. That's a regular 4. It's multiplying. Cube root of 2. So this answer is 20 cube root 2. So this was actually Friday's lesson. But we didn't really get into it. We mostly did the list, and then there was an assignment on Big Ideas Math. We're in that same section. So right now I want you to go to page 797, 9 through 12. time is it? No, that's classwork. The assignments on Big ID is math. What? So if you want to start logging in, like, you can. Because you know it's going to take a while, you can. But
I'm tired. Like, I don't want to be here. We should give us another week. I woke up early. I felt so weird.
alright, so we're upgrading this immediately to include operations. Oh, the paper test? Yeah. You want to take it tomorrow? Alright, operations with radicals. So you can combine like terms just like variables. So on number 9, it's 3 square roots of 2 plus 10 more square roots of 2, total 13 square root 2. You add the number in front, keep the radical there. That number in front is called a coefficient. So the number 9 set up nicely for you, and you can always go back and use your examples to help you with this. Look at the examples. I'll just go off what I'm doing with you. So the only mistake people would make on a problem like number 9 is maybe turning this into 4, right? But if you think about it like a variable, 3x plus 10x would be 13x, just like that. So don't change the radicand. Okay? Now, number 10, they're not like terms, so we can't do it. You can't add or subtract radicals that aren't like terms. So we'll have to simplify to see if we have like terms. So when I look at 7, these are square roots or cube roots? Square roots. 7 doesn't square root. I look at 63 and I gotta think, could 63 be simplified? Does 63 divide by 49? 36? 25? 16? 63 divides by 9. So before we can even do the operation, we have to use this skill we just practiced in Bellward. Yeah. Okay. So I'm going to change this one before I can even do the subtraction. 63 is the same as 9 times what? Yeah. How many people know 63 is 9 times 7? It's just it's a really big disadvantage if you don't. It's a bummer. You're going to have to work harder. If you don't know your multiplication tables very good, you got to use your calculator. You'll have to check the numbers. 63 divided by 9 is 7. You got to use your tool if you don't know your multiplication tables. Yeah. Yeah. All right, so the square root of 9 is 3. Square root of 9 is 3. The 7 doesn't square root. There's a 6 in front. So we've changed the 9 to 3. And so this is now negative 18 square root 7. The 4 is still here. So it's 4 square root 7 minus 18 square root 7. Initially, they did not seem like they were like terms, but once we simplified this, they both have the same square root. So this is 4, take away 18, negative 14 square root 7. How'd that one go? Okay. Now we did addition. It's all operations. Did addition, we did subtraction, and now we have to multiply. You can multiply anything. This is the square root of 22. Yeah, multiplying is always way easier than adding or subtracting. Uh-huh. Mm-hmm. Right. There's just less rules with multiplication. And so this one, 2 negatives make a positive. This is the cube root of 40. Now I'm going to check. 40 divided by 27? No. Does 40 divided by 8? Yeah, it does. 8 times 5. So this can be rewritten as 8 times 5. This is the cube root of 8 times the cube root of 5. And the cube root of 8 is 2. So that's it. Now I'm going to open up the big ideas so you can try to start answering questions. This is a difficult topic. I think we only have this and then check these.